To understand where enterprise AI is breaking down, look at what it was originally asked to do. The first wave was about answering questions, summarizing documents, drafting emails, and querying knowledge bases. It was a useful but inherently low-risk operation. If a chatbot generated a wrong answer or a hallucinated summary, a human operator was still there to catch the mistake before any action was taken. The next wave removes that human safety net. Enterprises are now deploying autonomous agents that interact with live business systems directly. These systems are being tasked to route work, approve or deny insurance claims, determine financial eligibility, and trigger systemic workflows. By taking these actions, the AI becomes the executor of a regulated business decision. This diagram models the current architecture most enterprises use to attempt these automated decisions. Data flows into a retrieval-augmented generation, or RAG system, which feeds context to a large language model. That model instructs an AI agent on how to act. The vulnerability in this stack sits right in the middle. A large language model is a probabilistic engine designed to predict language. Its outputs carry inherent variability. But enterprise operations are rigid. They are bound by strict contracts, compliance regulations, rate tables, and standard operating procedures. This creates an architectural conflict. If an AI agent denies a claim or approves a loan, how does the enterprise definitively prove why it took that specific action on a specific date? When audited, a business cannot point to a probabilistic prompt as a legally or operationally sound justification for a decision. Governing these decisions requires a dedicated, deterministic infrastructure layer built specifically for AI. You cannot force a probabilistic reasoning engine to act as the rigid system of record for regulated business decisions. The industry's initial response to this problem has been to throw more context at the model. The common assumption is that feeding an LLM better policy documents through a RAG pipeline will eventually eliminate decision errors. Retrieval is effective at finding the right paragraph of context, but retrieving information is not the same as executing a decision. RAG cannot guarantee structured outputs. It cannot handle missing evidence deterministically and cannot generate standardized reason codes required for regulatory compliance. We can see the market reality of this architectural flaw in this chart. Look at this heavily contrasted rising segment. By 2027, Gartner projects 40% of agentic projects will be canceled. Those failures are driven by two issues: unclear governance and runaway costs. Putting a large language model in the live runtime path means every single operational decision requires a variable inference call. You are paying token economics for routine business logic. The compounding math is real. Some enterprise software vendors are seeing AI inference expenses approach 10% of their headcount costs. Relying on RAG and prompting to execute business logic creates a system that is too expensive to scale and too unpredictable to govern. Fixing the enterprise AI stack requires a shift in how we handle business logic. Policy must be compiled, not prompted. Sertainly resolves the governance and cost issues by creating a physical architectural break between AI interpretation and AI execution. Large language models are highly valuable for interpreting complex language.
But their utility belongs in the build phase, not in the live execution path. By extracting business logic out of agent prompts and compiling it into rigid code, enterprises achieve predictability at runtime. Sertainly's architecture is a 4-layer pipeline. It starts at the source layer, where complex regulations enter as unstructured text. Data then moves to the build layer, the only place Sertainly uses AI. An LLM extracts the logic, passing it to a human expert for approval. Once approved, logic compiles into a locked decision package. Notice this hard boundary. The AI node is now completely removed. The system enters the runtime layer as a deterministic API gateway. Clean data interacts with the package, producing immediate single-path outputs. With zero LLM inference, the API evaluates deterministically. Exact inputs yield exact outputs every time. Finally, the governance layer captures every detail, filing the inputs, rules applied, and outcomes into a structured audit database. This separation allows an enterprise to harness the interpretive power of an LLM at setup while executing with the mathematical certainty of a rules engine. To see how this enables autonomous agents to operate safely, we look at exactly what a Sertainly decision package returns to the enterprise system. Instead of a conversational paragraph, the API returns a structured JSON payload.
It contains definitive actions, approvals, denials, or precise calculations. If a submitted claim is incomplete, Sertainly deterministically halts the workflow. It returns exact instructions detailing the specific document the agent must collect next. Every payload also includes a trace and replay record, logging the specific policy citation and the package version used, making the decision instantly auditable. Providing AI agents with structured, constrained outputs moves them from unstructured guessing to safe, governed execution. When you scale these agentic workflows to millions of daily API calls, this architecture dictates a new financial reality. This graph tracks cost trajectories over volume. Competitors who leave an LLM in the runtime path inherit compounding token costs that rise with every single transaction. Because Sertainly compiles its decision logic, API evaluation requires 0 tokens. Its cost trajectory remains flat, regardless of volume. The cost to run a Sertainly decision is the same whether it executes once or 1 billion times. As agent deployment scales, removing the LLM from the runtime path transitions from a technical governance feature into a structural economic moat. Predictable enterprise growth requires fixed marginal costs, which probabilistic inference models cannot provide. The result is a single, versioned decision package that serves as the system of record, executing the exact same logic universally across the network. While AI agents are the immediate wedge for this technology, this compiled policy layer is not restricted to AI systems. This diagram shows how the exact same Sertainly decision package can be called simultaneously by an AI agent, a legacy ERP, a customer claims portal, and an internal billing system. Sertainly does not replace LLMs, agents, or systems of record. It provides the connective tissue those systems are currently missing. As enterprises deploy AI to take high-stakes actions, Sertainly provides the decision infrastructure that makes those actions safe, auditable, and economically viable.